Hey everyone, welcome back to the channel. Let's get started with the problem reading books. In this problem, we need to find the minimum total time required for two-person to read all the books, given that they cannot read a book at the same time. So in the example, let's say we are given with three books and let's take the unit of time required to read books is hour. So this first book requires 2 hours, this second book 8 hours and 3 hours. So in total, we require 16 hours so that these two-person can finish reading all the books. If we think this problem, then we can think that this problem is getting divided into two segments. The first segment is being when we are given with one massive book, which is let's say of size 20 hours. This is one massive book, and the other books are comparable size, let's say 2 hours, 3 hours, and 1 hour. So we can clearly say that the overall time required would be governed by this massive book of size 20 hours, and hence that would be 40 hours in total required. On the other hand, when we are given with the books of comparable size, then we need to dig a little deeper and study. So let's take the first scenario when we are given with massive book. So let's say the massive book is of size 8. The first person start reading it and the second person can finish easily those two books, and he's sitting for idle because there is no book left. And once the first person reads the first book, 8-hour book, then the other person can read that 8-hour book, and the first person can read what the first person or what the second person was reading, right? So this we can say is like they eats off each other, right? The humongous book eats the time required for the smaller book. So in the answer would be 16. Now let's take the comparable case. In this, we are given with the comparable size book, and let's see what happens. We start with random. Let's give the first person this 10-hour book and the second person reads the 9-hour book, the red one. And that is for sure. We don't want any person to sit idle, right? So we just give the book we have. So we give the 3-hour book. At this point of time, we see which book is being not read. So clearly, this first person reads this. Now we give this to the first person, right? So we give 9-hour book to this person, and this point of time this person can get what the first person was reading, and now we can give this person the brown book, right? So clearly, if we see at this point, this portion and this portion is exact balance of each other, right? And similarly, this portion and this portion is exact balance of each other, hence they are balancing off in one or the other. And you may be thinking this is because of the example I took, but that's not the case. Let's see how we can arrange these books. We have three books, so we just in total we can arrange in 3 factorial way. So which is 3 factorial will be 6. So we have 6 different option of books: 10, 9, 3, 9, 3, 10, and so on. So let's see this on number line. This is the R, and let's start with the 10, 9, 3 and 9, 3 way of the order of the book. So first person start reading the book 10-hour, then the 9-hour, then the 3-hour. Time required is 22. The other person is reading 9-hour book, then he's reading the 3-hour book, and then this is reading the 10-hour. So in total, we can say they require 22 hours to finish all the books. So we have just picked the first two from our arrangements. Now let's try with some other in 310 and then 39. So first person reads the 3-hour book and the second person is reading the 10-hour book. Great. Now the first person start reading a 10-hour book, which is not because this first person is reading that book, right? So we can't give this book to the first person. So this basically this arrangement is not possible. And also we can see this is clear sitting off, right? And if we try other possibilities also, then also it's not possible, which was the case here also. So we can see in the given arrangement there will exist a one solution or perhaps two which will balance each other and will give the minimum time required, and that we can also understand because of there is no increase in the book total time, right? We have book, we read in whichever order. In the case of comparable, the other person will have the same symmetry, so they are going to make balance, and there is no increase in the duration of the time required for the book because the reading capacity is same for both person. Hence that's what the total time would nothing but the just the summation. We'll see in the code. So this is the case, another example of balancing of where we have 2 4 6 8, and clearly we can see that the first person is start reading this 8 book and the other person reads 2 4 6, and this portion is just the symmetry of this, and the first person reading order is just the same for the this second person. So the total time is nothing but the summation. Okay, let's try the code of this now. So basically there are n books, and these are the two person who need to finish them all. The first line will have the number of books, and the second line will have the time required to read each book. So let's have the number of books. Then let's create a vector which is for book time. This is the basically array of book time we have, and let's get the input. And also while we are having the input, we can do the summation. And why this is required, why we need to do the sum, because we have seen when we have comparable size book we need to do the summation. So let's do here only. So let's do the summation of book time. Then we need to have in consideration the time taking book. If this is the case of the big book we are talking about, the massive book, so that let's have the time taking book with us. So this we can easily do by max element, book time dot begin and book time dot end. So we have this, and let's define the first person time, let's call it j time, and give it to the time taking book. You will see in a minute why I'm doing this. So basically this refer to this, and the other person will be having k time, which will be summation minus the time taking book. Now if let's say j time is greater than k time, why this? If the person is reading the humongous book, let's say of size 20, which is the j time, and the other summation in total summation of the book comes as let's say 24, so summation 24 minus 20, this would be 4. Clearly j has to read this massive book. On the other hand, the k person has to read the first book, which is the massive book. We will subtract off just this small book, which is 4-hour book. So clearly this is the j is reading the massive book. So in that case what will be our result will be, it will be simply the big book into 2, right? Because the first person has to read the 20-hour book, the second person also has to read the book. So in that case we will have, let's define the result as ll total time equal to 0, and we will simply give the total time as the time taking book into 2, right? Because that would be our answer. But if that's not the case, what's if they have the comparable time? Then it is more simple. We have to just written the sum, because we have seen when it balances there is a symmetry, so it is just the summation of the books, and at the end we can happily do the printing operation, and that's it. We are done with the, so let's try to submit this, and it has been accepted. Great.